Welcome to the Automation Village, now the most popular automation show in the Benelux region. I'm Chris Little.
And I'm Dave Spencer. And some things coming up this hour: a drunken drone on Mars.
We play I/O tag with a programmer.
We guess which panelist is actually an AI.
A stranger steals Dave's rocket.
Chris has a shocking interview.
And two of you win prizes for participation.
This is the Automation Village.
And welcome to the Automation Village this month. This is a show for people who like things that control other things. And over the next hour here in the Hall of Justice, Dave and Natasha and Pete and Keith and I will bring you a cornucopia of automation goodness. But first, we're going to open up with a little segment we like to call Robots of Mars.
That's right. This is our little soap opera. So, Chris, it was kind of a spicy month on Mars. The Perseverance helicopter decided to go a little bit rogue and try some aerobatics as opposed to its very gentle prescribed flight. So this was actually caused by some competition, a change between the two computers. So the rover has two navigation computers on board. The first one uses inertial measurement, so they're taking using pictures of the ground, and I guess that's more analogous to say how your mouse would work, where they're taking these pictures and overlaying them, but a glitch in the photogrammetry caused the timestamps of the photos to become mismatched.
So, Dave, it sounds to me like what you're saying is that drone was drunk. So luckily no one was there to make it walk the line down the middle of the road, but it sounds like it worked out in the end. Is that right?
Yeah, so at the end of the day, so despite the thing, as the rover was going along, it was really rocking back and forth, which really exaggerated the situation. And I've heard that it actually did a full loop while it was trying to transition from A to B. But what ended up happening was it did reach its destination without crashing, and then that switched from the navigation mode back to the landing mode, where it's using fewer sensors, and it was able to make a successful landing. And it's carried on. It's done 2 missions since then, so a big tribute to the team at NASA who was able to create that patch, send that to the rover, and get everything back up and running smoothly.
It's amazing that you were pointing out that basically all these machines need to be able to do all this stuff without anybody doing anything because there's such a latency between the Earth and Mars.
Yeah, that's right. And if you'd like to read more about exactly what happened, I think Natasha's going to post something in the video chat there, and you'll be able to see that. Also, if you look at the flight log, you'll see that, yeah, exactly what you said, Chris. The duration of these flights are right around a minute, 2 minutes. And so, yeah, it's the rover's completed its mission before the telemetry has even said that anything's begun to happen. Also, for anybody who likes our Rocket Lander Challenge, right, if you go to the link that Natasha had sent, you can go and find a spot where they've got a post under their activities for kids where you can code your own Mars helicopter video game.
That's really great. So now I think it's time to go to our prize draw. So those of you who've watched the show before, you know that just for showing up, two of you will have the chance to win a $100 gift card from a popular online shopping thing. And so to do that, basically all you need to do it right now, open your email. Go to your computer, use your mouse, open your email, open up a new email, type in the field natasha.lutz@trihedral.com, and then wait patiently. And at some point, we will shout at the screen, "This is the code phrase." You'll then type that code phrase into the subject line and hit send, and two of you will win prizes.
Yeah, that's right. So we're looking forward to that. And before that contest, and again, it will be very clear when that contest is, but before that contest, we're going to go over and we're going to speak with a programmer at VTScada.
Hey, Jenny, how are you?
Hey, guys. I'm doing great. How are you two?
Great. So what's your work situation look like these days? You're not in the office. What have you set up for yourself to work in?
I was going to say, as you can see, I'm still in my living room, but I did lug my computer home from the office, so I've got quite the setup taking up the corner of my living room at the moment.
So hopefully you've got time now to do some tips and some tricks.
Yeah, so today I'm going to do some tips and tricks about high performance graphics. So just a bit of background about, what are high performance graphics? It's a bit of a buzzword these days in the SCADA industry. But basically, it's an approach to HMI design that overall is trying to increase the operator's awareness of what's going on in their system, and particularly to bring attention to when things are just not quite right, when there's abnormal conditions in the system. We often describe this as improving situational awareness, and there's some principles that are used to try and implement this in systems. The two big ones that we're going to talk about today are limiting color use. So you'll see a lot of high performance HMIs are very gray, very limited use of colors. Things like black means off, white means on, instead of green and red. And this has a sort of added benefit of being more accessible for people with vision issues, such as color blindness. It becomes very clear when there's something, wrong. It's sort of very monotone when everything's functioning as normal, and then very flashy when there's a problem.
Because for a lot of fancy HMIs that people have created, you can't tell whether that process is having its best day or its worst day. It just looks very fancy and colorful.
Exactly. So this is the concept behind this, is sort of everything is boring unless it's actually exciting. So,
that's a good way of putting it.
And the second characteristic is that on the page itself will be trends and stats and data like that. And the idea there is that operators don't have to navigate to different pages to find out what each piece of equipment's been doing for the past X amount of time. They have that drawn directly on the page, probably right next to the equipment or on an overall dashboard. Again, this is all to improve situational awareness. So those are the basic points. If you're going to design an entire app around HMI that's high performance, then there's a whole design process that you can go through where it really details the entire app creation from beginning to end. But today we'll just focus on the basics.
And while you're sharing your screen there, I'll just say that if you want to learn more about that, you can find it on, it's basically the ISA 101 design standard, so you can look that up on their website.
Yeah, exactly. So here today, I'm sharing my screen, and I've just got a very basic irrigation system is kind of what I've got here. We've got 2 tanks, some pumps, and some valves to water vegetables, whatnot. So as you can see here, we've implemented the 2 basic principles of grayscale, limited use of color, and embedded trends. So far we don't have too many trends embedded, but you can see here where the tanks are. We've got a spark line to show what the, how the tank level has been changing. And also here an analog bar that shows you what the current level is, what the trend has been over X amount of time. And this blue bar in the middle shows us what we expect the tank level to be. Also, we can see here these bright colors. This is where the alarms would be on this item or on this tag. And there's sort of a debate of whether or not you should put these lines when you're not in an alarm state. That's, I think, more of a personal preference. But again, we've got all grayscale, simple graphics. That's the big 2 principles we've got here. So today we're going to design just a little trend widget that we can embed on our page. So in the Idea Studio, I like to have this backed up a bit. We're going to create a new tag widget, and we're going to connect it to the IO and calculations tag. And we'll call this high performance trends. Okay. All right, so in this widget, let's go to the widgets. We've got the high performance folder right here. So on this widget, I'm going to put a spark line. And what a spark line is it's basically historical data. It's showing you get to pick, as you can see here, the time span. So for example, we can see the past 60 minutes of data, the number of points you want to plot, whether or not you want to show alarms, and whether or not you want to show the tag's expected range. For this, we'll want to link the tag. Oh, I don't want a reference line actually. But you can see here, there's lots of display options, and I like to put a analog bar indicator right next to it. So what this does is the little triangle, for me, points to exactly where the data currently is. So if we look at the properties, we can flip this indicator to the right side, click OK. And then the last element I'm going to put is an alarm icon. So this will let me know if there's anything wrong with my system. And I'll make sure that all of these are connected to the right tag, link tag, ion calculations. Ion calculations. And ion calculations. And again, very simple, very sort of limited information, but at the same time, you get a lot of, you do get a lot of information from these tiny little bits. All right, so that's that done. And now let's draw some flow meters. So we'll draw this one here. And make sure we get our new widget. So here we have a flow meter data widget, and we've got our flow meter right over here. So we could put this directly under, again, embedding the graphics. And then we're going to link this to our flow meter. Oh, we've already done that. Wrong one. Flow meter here, select. All right, and now that should work. So as you can see, the Sparkline is not working at all. It's just saying 0. So I'll make sure that that gets fixed. All right, so basically that's just the very simple parts of high performance graphics. Simple design, embedding your trends, and very limited use of color, because when you have an alarm, you want that to be the thing that grabs the operator's attention. You want the operators to be able to respond to abnormalities in your system. And by doing that, we can improve our situational awareness, avoid catastrophes.
I can't imagine anybody covering more territory in such a short period of time. Thanks, Jenny.
Yeah, that's great. Thank you, Jenny.
Hey, no, you're welcome, guys.
By the way, just bear with us. Normally our show is hosted out of North Carolina, produced by Pete and all of his amazing equipment. But this month, and this month only, we've got Keith Donaldson in the UK, who is the producer. So we're having a few troubles with some of the technologies we've been using. So hopefully our volume's improved. Let us know in the chat. I'm sure you will. Yeah. And in the meanwhile, let's go to DataWave with Pam Moss.
Well, thank you, Dave and Chris. That was really good, Jenny. Thank you very much. Really appreciate that. Welcome, everybody. Pretty exciting. I had attended our first in-person conference in Pennsylvania this week, so a shout out to the Pennsylvania Water Environment Association. Thanks for at least being one of the first in my circle to try this in person. And some of the guys from VTScada were there, so we had a good time.
That's
hanging
great.
out. So a shout out to all my friends.
Oh.
Hey,
Pam,
we lost
I think
Pam.
Pam's frozen,
We have
or
just
she's
lost Pam
making
there.
she's pausing for emphasis.
I think we've lost
So,
Pam.
Chris, so while we just wait to see if we can recover Pam there, we know that she's traveling. She's traveling today, so she did give us a heads up that our connection may be a little intermittent. But we'll just give it a second, see if Pam comes back. In the meantime, like he says, I just want to reflect back on some of what Jenny had shown there. I really like that high performance widget, that bar graph that has the trend in it. It's got the value. You can put in the expected value. So if it's taking time to go to a set point, you can put that in, and also that expected range. I think the expected range is my favorite part of that, because somebody who doesn't know anything about the system can go in and see if not only if you're into or out of an alarm, but if you're outside of a typical condition, and that makes it pretty notable. So
It's true.
what I
and
think we
that's
might
really
do,
what was lacking from what you might call a traditional SCADA HMI, which is more sort of like here, people were more. It was more about, hey, look at our pretty graphics that represent this process.
Yeah, that's right.
This really gives you a sense of bad thing happening now, or
Yeah.
look out, bad thing happening.
And you see people who are trained in the system very well. Oftentimes, like you hear stories about somebody who would hear the relays clicking in an old system, and he knew the beat of the relays. And if the beat was off, then he knew something was wrong with the system. Well, obviously, somebody from the outside needs to spend a lot of time with that system to understand it. So in these more modern systems, you can take somebody and put them in front of a system, and they should have a pretty good idea of the health of that system without having a huge amount of detail. So getting back to the roundtable, I wonder if we should have Pete take over the hosting of the roundtable and kind of carry on.
Pam will, hopefully, if she shows up again, we will insert her.
Sure.
This is the joy of live television. So
yes, it's all live. So having great fun. As always, this is how you know it's live, isn't it? So
that's right.
So when we spoke last, Ian and Lee, and when Pam was here as well, we were discussing about kind of automation in a number of different guises, I guess, really, and we were kind of talking about things like AI, and we were talking about machine learning. So I think, Ian, you were going to actually because people sometimes talk about AI and defining what is AI, because AI could be a what, so maybe you want to take it from there.
Okay, I gladly will. And we're going to start with a basic mathematical explanation of what machine learning and AI are, because if you do that, you realize that they are practically one and the same thing. It's simply that from afar, things start to look magical. So if it is machine learning, what is going on is you have written an algorithm that is capable of taking data that has come in and using it to adjust how it responds to information in the future. In other words, the events of the past have an impact on the events in the future. Therefore, surely you need to be using a mathematical process by, with, and through which you can incorporate that data. And that is how you create something that's machine learning based. What makes things start to look magical and AI based is when you start using an additional layer of algorithms which are looking at the distributions, changing the types of distributions that you look at over time, because relationships shift, including those that are important that inform the algorithm. So the words to use when someone says, "Is this? I'm selling you something that's machine learning based," just ask them whether or not it's Bayesian based, and that'll get you a heck of a long way to finding out whether or not it truly is machine learning. Now, the thing that Jenny was doing, where a human is staring at the screen and seeing whether or not the equipment is in fact alarming, the alarm trigger, and then the inference as to whether or not something is going to collapse in 5 minutes versus 15 is stuff, monitoring and prognostics, that is tremendously benefited by applying machine learning to it, because you can.
So I think that maybe Ian's got my disease now.
Oh my God, this is like round robin. Oh, you're
I'm
back.
gone.
You're back again, Ian.
Take
I
it to
think
someone else.
This is
we
going to
learn
be called
how
the.
to adapt and overcome, don't we?
Yes.
We certainly do. I got a few internet issues here. Fort Lee is practicing their artillery, and I just blanked out. So sorry about that. Ian, thank you so much for jumping in. But I will say to everybody here on the Automation Village, getting to work with Ian, Lee, and Pete, I mean, all these folks is just amazing. We just take over for each other and run with it from our practice, don't we, guys?
We do, so it's all great, and we've thrown poor Keith, who's manning the controls in Scotland, about 10 curveballs, because there's stuff happening. Anyway, we hopefully everyone's still enjoying the show, and I'm sure you will. There's plenty to get out of it. So Pam, maybe back to you. So just Ian was giving a great kind of definition about what AI was, and even down to the fact that he mentioned about Bayesian type calculations. Just ask what is behind the AI, because not all AI really is AI. I guess that was the point. So back to you. You've the reins again.
Thank you, Pete, and thank you, everybody. Yeah, I mean, how really, we got into this conversation, everyone is just talking about good quality data, and then what can we do with the data? What's really practical? Certainly in my world at Hawk, we want to make sure that the data is good, whether it be process instruments, lab instruments, field instruments, because you don't want to make bad decisions on bad data or erroneous data. And then we started talking about with Lee is, okay, what's manual for plants? Then, the whole adage words coming out now of what is machine learning, what is AI, what is it really? Because there's a lot of, right, Ian, a lot of words being thrown out now. So it's really great that Ian knows that world to really describe that a little bit more. Because in my world, it's about knowing what's happening in the instruments. When is maintenance due and all that? And then using that data and process management to control your phosphorus, control your ammonias, control your coagulation. But so many ways that can get there, starting with statistical process control and moving on up the pike. So Ian, thank you for explaining to the group. I appreciate that. But one thing we talked about is we want to make sure that what does this all mean from a practical standpoint? So Lee, I'm going to jump over to you because you're running a nice wastewater plant. There were some really cool things there at Riviera in Alabama. What is your take and what are your folks' take on this?
Well, artificial intelligence is alive and well and being ran at Riviera Utilities in Foley, Alabama on a Narita wastewater treatment plant. Now, what you would expect with a normal wastewater plant is that you would have a PLC doing local control, controlling blowers, controlling valves, and that is a proper way for a plant to be controlled because of the reliability that is required. Now, in our particular situation, this PLC feeds into a server-based control algorithm, which kind of looks at historical data and uses artificial intelligence for deriving what could happen. It's a feed-forward system where you see the reference to the past data and you make adjustments to the control algorithm based on what's going on with current conditions. And so what also happens is this data is shared out over large number of plants across the world. They kind of take the data and strip away who owns the data for security reasons, and they take that data and they refine their core algorithm, which in turn then can predict that say this plant could be trending towards having a problem. So that provides the operator an advance notice that, hey, kind of like the spark line, you're looking at the spark line and you're seeing that things are going out of control rather than just having one point of data. So, but the key thing is we cannot and must not, due to our reliability aspect, give up all of our control locally because of data security. And all of this artificial intelligence all hinges on the ability of us to maintain data integrity and protect our networks and feed this information forward. Does that kind of help you understand? But this has been a wonderful experience as far as not having to make adjustments when huge hurricanes come in, which have already happened to us this year. Welcome to 2021 in Alabama. We had for our first tropical storm here this past week, and it's a very turbulent world we live in, and having all these new tools can really help us protect the environment.
I would say, and before we go over to Pete and to Ian on the security side, I don't want people to be afraid of the black box or the algorithm, because we all know, and everybody here working with all of our, whether it's water, wastewater, power, airports, the critical operations is really important that those people really know how their plants run and understand what's going on. So how do you train your operators?
Yeah, that
side,
is...
then we'll go to the security side, because it's really important to me that they understand what's happening from that professional side.
That's an excellent point. And, I've already done 35 tours of this new facility. And one of the big problems is that people are concerned that this technology is going to replace them. and they're no longer going to be an integral part of the process, which is incorrect, because now you are just advancing the tool set that you have to notice things in advance and preemptively prevent the SSO, the ammonia bust, the TSS going off into the creek. It's just these are tools, just like a carpenter now uses cordless tools versus corded tools, and people that use accounting use spreadsheets. We all need to adopt these technologies because they multiply our effectiveness. Also, from a standpoint, we still have to know how to run these processes by hand. So the technology itself does not remove responsibility from us at a local level of knowing what's going on. We can't become, lazy and not know how that this valve is working versus this ammonia probe versus the lab data. We still have to keep that technology in use as be able to manually look at the data and to be able to make decisions. Does that help you understand?
Well, that's fantastic. So I know we're rushing this a bit because of our technology issues here. So let me come back to Ian and Peter. Just how do each of you address the question of security when we're running these more advanced processes? So Ian, I don't know if you talked about a little bit, and maybe we go to Peter. I want to talk a little bit about how do we work with our IT people to give them that information?
Certainly. So there are two aspects two sides to this problem. The first is that your AI is only going to be as responsive and as intelligent as the sensor arrays that are placed out there for it and the reactant system, the actuators they can reach. So from a cybersecurity point of view, there are two sides to this problem. The first is that an AI is a machine learning system is best informed by being able to reach out to the rest of the world and inform itself based on all the other instances of itself around the globe. And that gives you a much more reactive system. The trouble with that is the cybersecurity. That means the rest of the world can pass data in. So what you need to do is create duplicates of the system at two separate layers. And we will be providing one of these diagrams on the automation forum shortly. The second thing is you need to attend to your sensor arrays, and this is physical security. But if you want to trick an AI, the way that people tend to miss that an attacker will use is they'll trick the AI by tricking the sensors.
Okay, Peter, will you want to wrap it up with a little summary of what you've seen in your world as we wrap it up in this last minute? Thank you, Ian.
No problem. Thanks, Pam. So actually, I was even going to circle back to the whole idea of even kind of the fear of the technology, and some of you may have heard of Moore's law, which is going back to the fact that like the number of transistors in a dense integrated circuit, it doubles every 2 years, even though the cost halves. Now, what does that mean in real terms? Well, it's going back to the computers are getting faster and faster and faster, okay? And basically, if you think of it like sand or something like that, it's no matter how much kind of you put out there, it essentially gets kind of absorbed by the need. So where people get afraid about using tools like AI and all kinds of different things like that, what actually happens is that your need will outgrow the automation replacing your job that you're afraid about, right? That's actually the thing. So your computer, you could say, right, well, how many people are working, etc. Well, it's just you'll adapt, you'll change. Your job is going to be secure. Don't be so worried about the job because things get faster, broadband, all these different things get faster, and we just have a higher need to do more things. So I wouldn't be too worried about it.
Well, thank you very much. Always fun, and thanks everybody for being so flexible. But we will see you guys next month here on the Data Wave. So I'll throw it back to Chris and Dave.
Bye, guys.
All right, welcome to the Rocket Lander
Bye,
Challenge.
everybody.
Today we've got Eddie Noyce joining us from
Bye-bye.
MR Systems. How are you doing today, Eddie?
Great.
Cool. So, Eddie, you're going to have 3 attempts to land the rocket. It's the same as what we do every month. Take the rocket simply from the pad it's on, land it on the adjacent pad, and you'll win a $100 gift card.
All right.
So, whenever you're ready, Eddie, take it away.
All right. Let's see how we do.
All right, so it's a clean getaway. Eddie's gone straight to the thrust vectoring. I did warn him this is high risk. He's had excellent, excellent job. So Eddie did land this in practice as well. So, all right, it's good trajectory. It's actually looking really good. He's got quite a bit of horizontal speed, so we'll see if he can scrub that and get this down on the pad. His trajectory looks fantastic. This is looking really good. So can he get the rocket rotated? Oh, he's carrying just a touch too much speed. All right, so plenty of fuel left. Bring it down. All right, and decelerate, decelerate, decelerate. It's going to be right on the edge of the pad. This is going to, I don't know if I programmed the pixels that well on the landing zone. Oh no! All right, fuel's getting low here. Fuel's getting...
I'm not going to make it.
Oh no! The legs are out. But the ground is hard. Cool. That was a really good attempt. That looked like it was going to be absolutely perfect just until just above the ground there.
All right, so, let's try for number 2.
Attempt 2, here we go.
I go again with the
so
thrust
again,
vector.
You did a great job of this vector on the first one. And again, the trajectory is absolutely perfect on the end. All right, so a little lower attempt this time. I think Eddie's going for a high score here. Coming down, it's going to be a big pendulum-like swoop into the finale. Wow, this is looking good. All right, so we're coming back up, but also requiring a little thrust to scrub that speed. And I will see if Eddie can glide it back in. All right, you'll notice Eddie's got a drone in the background, so we are expecting high things here. And this is looking really good. This is now yours to lose.
Yes!
Oh, nicely done. Nicely done.
The Eagle has landed.
So that's just over 38,000 points. Great job, Eddie. That was a really nice landing. Lots of fuel.
Thanks a lot.
You didn't even get into the yellow. Not even a warning on fuel. That was really well done.
Yeah, that was crazy. That was way better than what we did in the practice run, wasn't it?
That was, yes. I think even if you were an actual rocket, you may have put that one on the ground for real. So that's great. Did you want to go again and try for a high score? Or
we'll try it. Yeah,
go ahead. One more try
for a high score.
Yeah, or see if you can do a flip.
Yeah. All right.
All right. So now he's officially, you've been paid to do this. You're officially a professional rocket pilot. Coming in, again, looking like a great trajectory. A little more aggressive than the first one. Okay, wow, he's pushing. Oh my gosh. He was right into the red. Alarm's going off, putting a lot of stress on the side of that rocket. Oh no. That was a great attempt. It was like, if you look back at that planar stress, you can see you went right through the alarm in the red there.
Yeah.
I don't know how you didn't blow up. You must have been right on the edge. So that was really good. That was going to be about as quickly as that could have been done. So, Eddie, thanks for joining us. Congratulations on winning your $100 gift card.
Thank you. Maybe we'll send some other people over from MR Systems to try again in future episodes.
Absolutely. Yeah. Thanks again. We really appreciate you joining us. Have a great day.
All right.
Eddie.
Thank you. You too.
And now questions with Nat.
Oh, actually, before we jump to that, if you guys want to have your chance at the Rocket Lander Challenge, then be sure to head to the Automation Village forum and post onto there.
Excellent. And now it's time for questions with Nat.
Hi, everyone.
Just want to say we have the best audience that always sticks with us through these technical issues. You guys are awesome. You're going to get rewarded for it. Remember, stay tuned for the code phrase. So my question is coming from LinkedIn, and they want to know, what is the difference between SCADA and IIoT?
Yeah, that's a great question. And I think that the backbone of that really is that if I were to answer it in as short as possible, I'd say there really isn't much difference. Ultimately, you're looking at who's using this typically. Is IoT, the Internet of Things, was generally something that people were doing at kind of a home automation level, whereas you had industrial automation that was using more traditional protocols. But those protocols over the years have really modernized into being ones that are analogous to some of the different technologies that you see in IoT and IIoT, to now being the exact same protocols. And, we're seeing that in the home automation world, there's been a lot of progress in trying to find different standards that actually are working for more than one company. And now we're getting to the point where we are starting to see some of those. And we're having more and more people, more and more of that sort of home automation technology in industrial automation, but used in very specific purposes. It's not something that's necessarily taking over. It's something that's being used analogous to in areas where a device may be remote and connectivity to that device is more intermittent. So, Chris, did you have anything to add to that?
Just two things. One is that still, for the most part, people are starting to trickle into the trade show booths and ask about IIoT. But when you really sort of push in on what they're looking for, really the answer to their question right now is still SCADA. They are not at a stage where adding edge computing is going to add any benefit, only complexity. But the other thing is that basically, lots of different technologies have come and have arrived that now we think of simply as SCADA, like DMP3 or report by exception. Those are things that now have become part of SCADA. So I think IIoT similarly is just simply another way to expand this ever expanding technology.
Yeah, that's right. It's more of a name for something analogous to what's already being done. And we see it now, in the home automation world. We wait for Google's weekly announcement on the IoT protocol that they are 100% definitely going with for the future. That, again, changes every week. And like I say, I could name half a dozen of them probably in the last few years that have been the next technology. And so in the industrial world, there's a lot of things that people don't necessarily think of right off the bat that come with that, and come with having these servers like the MQTT brokers being at the company level or the product level that we see in more devices that are associated with IoT. I would say it's SCADA automation. You're typically kind of responsible for your own data. But again, we're starting to see big data coming into more equipment, and that information coming from other hosted parties as well. So I would say they're all very tied together right now.
Awesome. So remember, if you have a question that you want Chris and Dave to answer live on the air, you can send it to me anyway. Email, social media, the chat forum, I'll find it and I'll ask them live next month.
Great, thanks, Natasha. So coming up next is an interview that with Raymond Choi and Mike McLaren of HV Logic. And what's kind of neat about this is that their customer, CNRL, has a very large, very distributed SCADA application across Alberta and Western Canada. And what HV Logic has done has created a high voltage power management system that can operate in and amongst this growing system of oil and gas infrastructure. So we'll go to that now. Joining us now is Raymond Choi, the Senior Power Systems Controls Engineer, and Mike McLaren, Senior SCADA Engineer with HV Logic based in Calgary, Alberta. Thanks for joining us, gentlemen.
Thanks for having us.
So can you tell us a bit about HV Logic and the work that you do?
HV Logic primarily focuses on the integration of digital systems that are specific to the electric utility and power industry.
Who make up your customers?
We're currently working with TransAlta, AltaLink, Canadian Natural Resources, and FCOR.
Right, you mentioned CNRL, Canadian National Resources. Can you tell us more about them, since they, I think, are going to be the basis of our talk today?
CNRL is basically one of the largest public traded energy producers in the world. They're an excellent client with a strong, diversified global portfolio of energy assets. And for them, operational reliability is critically important as their facilities are always on.
Now, can you tell us the story of how you started working with them?
Sure, yeah. So we started with a simple request. We were just called to help troubleshoot and resolve an issue with a vendor product that they currently had in place. As a vendor neutral systems integrator for the electric utility and power industry, we made some recommendations outside of the single vendor perspective that ultimately brought them a reliable and working solution with VTScada. It replaced a system that they were experiencing a lot of problems with.
So can you tell us specifically about the problem you were trying to solve with this application?
Yeah, the existing system was an energy distribution management system. And I guess in general, it just wasn't reliable. The DMP3 driver that's commonly found in power systems just was constantly failing, and it would stop communicating. The data would be stale, and there would be no indications of the stale data. That obviously had an impact to the high voltage operations team. The high voltage operations team just lost trust in the system as it could no longer provide adequate and reliable information for plant operations.
So tell us about the process and the sites that are being monitored.
Sure. So VTScada was implemented as a starting point to a growing energy distribution management system. The implemented systems monitor all the high voltage assets within the Horizon plant. So it was imperative to use a utility standardized protocol such as DMP3 so we could accurately have sequence of event recording at the sites.
Now, you're working with VTScada. Can you tell us the story of how you came to start using that product?
Well, basically, VTScada is an accepted platform for CNRL. They're moving in the direction of more or less standardizing on the product. On the power side, it was not brought in yet. They primarily used it along with the other drivers for oil and gas equipment and oil and gas products. For us, we're very familiar with the power side, obviously, and the DMP3 driver. There are very specific requirements for the DMP3 driver that we needed to ensure we implemented so that it worked well in a high voltage environment.
So tell me, what sites does this system monitor?
In general, basically, the sites monitors the high voltage facilities. So we monitor the high voltage substations. We also monitor the generation facilities. They got cogens there in which we monitor the associated facilities for the cogens. And that's primarily the basis of the monitoring system.
Right. And now, what were your goals in designing this new system?
The initial goal is to just provide a reliable real-time monitoring of the high voltage assets. The long-term goal that we have in mind is to integrate more digital assets into the system, allow improved visibility, and also at some point we want to get to the possibility of doing some predictive analysis on their assets using the data that we're collecting.
Now, we talked about VTScada software. What were some of the things about that software that made it apt for an application of this kind?
When we first started the project, or in the evaluation stage, we needed to evaluate various products kind of moving forward and accepting a platform that was specific to the power system application. VTScada worked very well. There was some very nice inherent features that are part of VTScada, such as the seamless transition redundancy, the version management system, and just the ability to customize the application to our needs. Those are all very nice features. But some of the big requirements for us specifically for the power systems was the ability to update the system online and live. There was also a very well implemented native DMP3 driver. We wanted to avoid using a DMP3 driver that was external or OPC based or something like that. So this was a very nice feature that the DMP3 driver was developed by Trihedral. And this was very important for our application.
So what can operators do now that they couldn't before?
I think one of the big things that Raymond just touched on as well is the custom applications and solutions. So whether it be on the cloud or client servers, when we say custom, we can really dig deep into the power system requirements and provide a solution because we're electrical engineers first. We aim to understand the power system requirement, then we look to provide the digital solution for that.
That's great. So I always like to ask, what are you most proud of in the finished system?
we're always proud to just provide a solution that works well and the customer is happy with the result at the end. Sometimes no excitement means things went really well and everything operated and ran, as we would expect. We basically, with this system, it was a live operating plant, and everything, the plant had to be operational while we implemented the system and while we worked on the live RTUs. I think we were proud that we were able to execute the system pretty much seamlessly. It kind of flew in under the radar. We implemented everything, no disruptions to existing plant operations, and then we got the system up and running for the high voltage operators again.
That's great. So you've been using VTScada for a while. Did you ultimately take any training along the way?
Yeah, 2 of us attended the basic course here in Calgary. But I would say most of our experience was gained through the execution of the projects and actually doing the work. But I will say Trihedral has provided great support, very responsive. So it was very helpful as we worked through trying to get to this solution for the customer.
I'm glad to hear it. So tell me about how this application handles redundancy.
So the systems are implemented on virtualized redundant servers. While also having 2 redundant VT servers, we have a seamless failover system now. So it mitigates the risk of failure a little better while providing a degree of management and disaster recovery options if one of the servers was to fail.
So how did it go during the integration and commissioning of this application?
In the high voltage industry, it's important to be able to perform and upgrade seamlessly on a live operating power plant system. So that can bring its own challenges and definitely some extra risk. We updated the remote sites, GE D20 RTUs that were on site, and we migrated to the new EDMS system live. So we were able to kind of overbuild the system. So we still had the old product running, and we just added new links to the VTScada platform. So we performed a live cutover during commissioning. The system's fully in service now, and the operators provided positive feedback on VTScada.
Well, congratulations. So now, what advice would you give to another utility or another organization looking to implement this kind of system?
I would say know your application. There are a few products in the utility and power industry that are fairly canned solutions. So they work well for certain specific applications, but as soon as you go custom or larger applications that are required, such as in wind, solar, gas, or hydro generation, it's important to have an application that's highly customizable and flexible for everything you want to throw at it.
So now that the application is up and running, what are your plans for it?
Due to the digital transformation in all aspects of our lives, and the power system industry is just anticipated to continuously grow, we intend to continue to provide highly specialized industries-focused services to this industry, while delivering solutions that serve the industry well in both an operational and economical perspective. We're constantly looking to be creative in trying to bring alternative solutions to an industry that is not necessarily moving as fast as the technology is.
So if someone's watching this and they're excited about what you just talked about, how do they get in touch with you?
For us, we're always glad to have people reach out to us and start the conversation. We can be reached by phone, email, website, and LinkedIn. Various platforms definitely would be glad to help in any kind of way.
Well, today we've had Raymond Choi, Senior Power Systems Control Engineer, and Mike McLaren, Senior SCADA Engineer with HV Logic in Calgary, Alberta. Thanks a lot, gentlemen.
Hey, thanks so much for having us.
Thank you.
This is the code phrase, my friend. You can put it in the subject line and send it to natasha.lutz@Trihedral. All right, is that enough of that?
I was going to say, and do it quickly.
So yes, type that in the subject line, instant or high performance. Type high performance in the subject line, send it to natasha.lutz@trihedral.com. 2 of you will win $100 gift cards from an online shopping thing.
That's right, and make sure you do it exactly how you see it on the screen, because it will be interpreted by a awful machine learner and not a human.
That's right. All right, so good luck, whoever wins, And now it's time for industry news. All right, everyone gather around the monitor. We're all going to share with you some links to the internet, to some automation related things. And first of all, we're going to go to Natasha for water and wastewater news. Go.
Okay, so my news is a Switzerland wastewater treatment plant became the first in the world with a combined ozonation and GAC system for micropollutant removal. And I have Tetra Pak showcased its new UHT 2.0 heating portfolio on World Milk Day. It's a thing in support of dairy's commitment to innovation to reduce their environmental footprint. I'm going to put some more information over on the forum later about these two topics.
Awesome. Thanks, Natasha. Dave, go.
All right. So as Duke Energy has kicked off an effort to renew the operating licenses of all 11 of its nuclear power reactors for 20 more years, first energy scandal disrupts the nuclear industry in Ohio. So I don't know if you guys have heard, but according to Power Magazine, multiple political figures have been indicted for allegedly taking bribes to protect the state's nuclear power industry. Two of those accused have actually pled guilty to this, and the beneficiary of a $1 billion state bailout, First Energy, is reported in talks with prosecutors. So it's a mixed month for the nuclear industry.
Well, it's only nuclear power, so it's probably fine.
That's right.
Okay, over to you, Pete. Tell us about general industry.
Yeah, I certainly will, Chris. And actually, Dave, you have a nuclear reactor, don't you? I think out the back. Do you see that?
This is. It's in my submarine.
No worries. So, right. So my two pieces. I've one from our friends at automation.com, and it's kind of a bit of a did you know, but it's quite interesting to look at this. It's actually to do with compressed air and air audits. And did you know that 20% of waste when it comes to compressed air is in leakage? We say it's 20% leaks, if I can say that correctly. And if you consider the compressed air is one of the highest energy consumers in the world, the whole article is based around fix those leaks, one leak at a time. And you could actually be saving massive energy. It's less about adding capacity. It's more about making use of what you have. 20%, pretty high globally. And the second thing is just with our friends also in controlglobal.com. And it's a great piece. It's the top 20 secure PLC coding practices brought out by the ISA Global Cyber Security Alliance. It's a great article, great download. And I'd also like to kind of shout out that we also should, have a look, if you haven't already, to our own Ian Schmertzler from Dispel. Brilliant stuff that he's actually put in the forum this month. So have a look at that as well on cybersecurity. Really, really practical.
That's great. Thanks, Pete. And now I'm going to share a few things on the oil and gas industry. And these are about two technologies that you hear about a lot these days, but you don't normally associate with oil and gas. So one of those, which is shared on verdict.co.uk's website, digital twins being used in the oil and gas industry, how futuristic tech is keeping fossil fuels alive. So basically, it's an example of when times are tough, industry invests in efficiencies. So this is basically using digital twins, especially in the time of COVID. It's an easier way to model and do predictive analysis and predictive maintenance. And it's now, so there's an interesting article about how they're using that. Also, my digital twin has a goatee. The other thing is Business Wire is using quantum, has a nice article about using quantum computing for oil and gas. So you've probably heard of that as being the emerging technology that will one day make your password not so secure. And they're talking about over the next 30 years that becoming truly an emerging technology that will basically wipe away all encryption everywhere. So hopefully we'll have time to get out in front of that. But in the meanwhile, there's applicable uses of quantum computing, which basically is using the properties of quantum physics to store data and perform computations. But you knew that already. But right now, people are using it like ExxonMobil, Shell, BP. They're using it to again, find problems in their system and also to do something called quantum chemistry. So again, that's something to look for. So two interesting articles that I'll throw in the chat. Thanks, everybody.
I also wanted to say Pete mentioned our friends over at Control Global, and Pete himself has a featured article over on Control Global right now. So when you're there, make sure that you also check that one out. And I believe the title is Inherent Version Control to the Rescue. So it's sure to be a good read.
That's right. So yeah, it was a great month for news. There's all kinds of interesting things there. So Chris's news required an advanced degree. Peter's news was very close to my mechanical engineering degree, where we wasted tons of compressed air creating a air-powered go-kart. So
nice.
On that note, let's jump over to our photo contest, where we had you guys send in photos of your impromptu workstations. These are your on-site workstations, which are typically horrid places for anybody to work, but you all love to share them with us, and we love to receive them.
Commissioning castles. That's what we can call them.
Yes.
Hashtag commissioning castle.
Trademarked.
So this is...
go
ahead.
No, go ahead, Chris.
Well, here just to kick things off, here's our president, Glenn Wadden, doing some important work in his commissioning castle with Tim Donaldson, who I think is on the live stream today. Hey, Tim.
Tim, how are you?
So I think we're just going to see the winners here, are we?
Yes.
Yeah, that's right, Chris. So we're going to jump right into our winners this month. And so first up, our honorable mention, Louis Mariquin. And next,
he's also on the line with us today. So
yeah, hi, Louise.
Hello.
All right. So first runner-up is B. Nielsen, and we really like this one with that chair. Just looks so nice. Although I think he should pull it out. It looks more like it's meant to be in the sun, not in the shade there.
Right.
I love the extension arm with a piece of ply. I think it's really good. It's for the mount.
Works as a reflector.
I do want to mention, though, I do have extremely similar wallpaper to that chair. I know Bart was saying that people were really ribbing him about that chair, and so now I'm thinking maybe my interior design choices.
Natasha, I'm so glad you said to that chair, because at first I thought you were going to say to that door.
Yeah, I was actually wondering on that myself, Dave.
All right, so let's go. The winner of this month's photo contest.
Nice.
Megatom.
So Megatom, yes, Megatom.
That's you can't go wrong with a cow. By the way, that cow was the lowest bidder on that project.
That's right. I just want to know what happens when he presses start or stop on this. I'm expecting that cow to do something.
It's an AI cow.
Very nice. Well, congratulations, Megatom.
Everyone can enter this contest. I will put the link in the chat to where you can enter your impromptu workstation photos. Each month we'll be back. As you can see, there will be 2 runners up and a winner. So anyone, even if you've won before or if you've submitted before, submit another photo and you're back in to win. So I'll put that in the chat.
Excellent. Thanks, everybody. So now that brings us to close to the end of our program. So let me take this moment to thank those who joined us today. Pam Moss at Hawk, Lee Kibler at Riviera Utilities, Ian Schmertzler at Dispel, Raymond Choi and Mike McLaren at HV Logic, Eddie Noyes at MR Systems, Jenny Bauer at VTScada, and Keith Donaldson, our producer under fire, who did a great job. Big hug to you, sir, in Aberdeen.
Great job,
Scotland.
Keith. Really well done.
We did everything we could to break you, and you are still standing. So finally, we'd like to do parting remarks. So Natasha, go.
So I am offering up a limited edition Automation Village. I don't know if this is coming through, if I'm holding in the right spot or not. Automation Village sticker to the first few people that comment over on the form under Meet the Team, Natasha, that says, send me a sticker and I'll send this to you.
Thanks, Nat. Pete, anything for you?
I just want to encourage everyone to subscribe to the forum if you haven't already. You might be just watching this on YouTube, and make sure that you do there as well. And we'd love to have you. And can I do a very quick shout out to my family over here in Ireland where I am at the moment? Hey, guys.
Nice. And Dave, anything?
Yeah, so I want to encourage people to post in the comments below this YouTube video. Let us know what you would like to see coming up on a future episode. If there's something you'd like us to talk about, then definitely give us a heads up on that. Also, I want to encourage everybody to download VTScada Lite. That's our free SCADA software. You can get going with that. You can get up and running. You can use it actually industrially because it is a full SCADA license. It's just limited to small systems and it's totally free. So the other thing is you may be thinking, I'd love to try VTScada Lite, but I don't have any I/O to connect to. And I'd encourage you to look at a video that we have from our producer today, Keith Donaldson, where he shows you how to connect and show the position of the International Space Station in a VTScada app. So Natasha will throw the link to that in the comments, and you can watch that video after this.
Great. Thanks, Dave. And finally, I'd just like you to take a second and think to yourself, who do you know who would enjoy watching this show? Just one person that you think would get a kick out of this and would enjoy this while they have their sandwich at their desk. And if you would mind just sending them a link to this video, because of course this will be live on YouTube as soon as the show's over, pretty much, we'd really appreciate it. That's really the best way to grow our audience. So once again, thanks everybody, and especially thanks to Pete's mom, who we met earlier today. And we will see you next month, July 22nd.
Cool.